right, so let's take a look at the story problem here. It says on a map, and this looks like the United States map, Minneapolis is 165 millimeters due west of Albany. And Phoenix is 260 millimeters from Minneapolis. And Phoenix is 368 millimeters from Albany. And they're asking to find the bearings from Minneapolis, so here, to Phoenix, or from Phoenix. So basically, when we're talking about bearing, it's asking what direction are you moving towards. So if you start here, what direction do you move towards? And when you're talking about bearing in specific, you are talking about like the compass and the angle from a compass. So let me just show you a better picture of what part A is describing. So if I were to draw a compass here, try to draw a straight line the best I can. Let's do it like that. There, that's a pretty good picture. And I'm going to do my best to draw this triangle that they've made. So let's say Phoenix is at the center because everything seems to be from Phoenix. Like notice this question's from Phoenix and this one's also moving from Phoenix. So that could be like our origin we're going to plot it at. And then it goes out to Minneapolis. So I'm going to shoot it out here. And so I'm going to call this M. And then it goes kind of like a straight path to Albany. Call that Albany. So A for Albany. And it produces a triangle when it does that. All right. And so when it's talking about bearing, it's mentioning like which direction is it moving at and what angle is it what it is moving at. So this is a little bit difficult to understand if you don't know about how like planes fly, but I'll try to break it down in simple terms. So first off, if we're going from Phoenix to Minneapolis, so it says Minneapolis from Phoenix. So if you're starting at Phoenix and you shoot out to Minneapolis, let's call this north, east, south, west. So obviously from Phoenix to Minneapolis, this is northeast. So what I want to figure out is from going in the north direction, how much of the angle do I have to turn east, this east here, to get the angle from Phoenix to Minneapolis. So I'm heading north, but there's an angle here that I'm trying to find. So that way I know how far to turn the plane if I were to travel in that direction. Is how I imagine things. In order to find that, that's the part that gets a little tricky. So I don't know what this angle is here, and I don't know what this angle or any of the angles in this triangle here. And that's the issue. But I do know the side lanes, so that might help. So I know that this is 216, this is 165, and this is 368. That might help me a little bit. So I have basically a side-side triangle or a side-side-side triangle. And that means I could probably use law of cosines. Other ideas. Well, what I'm thinking right now is this part right here looks really straight. In fact, so straight that I could probably form a 90-degree angle. And if this was on a line and this cuts through it, then if I knew what this angle is, I could figure out what this angle is and then figure out this angle. You see where I'm getting at? So right now, maybe the goal is just to find out what is this angle right here. I'm going to focus on that portion for a moment. So in that case, I am looking for angle M. If I were to create a formula for it using law of cosines, it might look something like this where, so if you look at law of cosines equations, you always start out with the length. And in this case, you have length M, and you want to find its angle. So this is going to be cosine of M. And then whatever you didn't use, so in this case, my P and A are going to be my variables that are inside. So it's going to be P squared plus A squared minus 2PA. Actually, I could probably move this cosine over. So I'm going to erase this and move it slightly over so it doesn't look so wonky. This is going to be cosine of M. All right, so I've developed my formula for this story case, and I'm going to try to find this angle. That means I need to plug in all the sides that I have, which I do have, and my side here is M that I need, and M is going, if this is Minneapolis, then M is 368, and I have to square that, so that's going to be a pretty big number. P is Phoenix, so across from that is that 165. I have to square that. And then my last number to work with is Albany, which is 216. So I'll plug in my P and A again, and then solve for cosine of M. So this part I'm going to just plug into my calculators because these numbers are ginormous. So this is going to be 1, 3, 5, 4, 2, 4. If I square that number, 165 if I square it gives me 27225. Plus 216 if I square it, I get 46652. If I take these three numbers and multiply, I get negative 71280, and cosine of M drops. So I can combine these two numbers to try to stay as organized as possible. So if I add these two, because they are like terms, I get 73881. I'll bring down this term here. And I can subtract off this number to move it to the other side. This helps me cancel. And so if I subtract, I get 61543. And now I need to divide off this large number here, 71280, to this side. So cosine of M comes down, and then I'm plugging this into the calculator here. So if I plug it in, I get, let's see, negative 0.863. And so I get a negative number. And some people might be suspicious of this. But one of the things I remember in trig in first semester is if I probably get a negative value for cosine, it's very likely I'll get an obtuse angle. And if I look at this picture here, M definitely looks like an obtuse angle. It was also the largest side, so there's a guarantee that this should be an obtuse angle. So if that's the case, I should be getting a very large side, and probably it's obtuse. So if I were to find, let's back up a little bit, the inverse cosine of this value, negative 0.863, and plug this into the calculator, this is going to give me, 149.655. And that is my angle. So I do get a obtuse triangle, and I should. So this time around, I didn't really use that, like pick the smallest side and find that angle first, because I was already given the picture and the side lanes. So I knew that this had to be an obtuse, so I can kind of trust that my math, as long as I get an obtuse angle, I'm probably in the right direction. So if I know this angle, and this is on a line, I can subtract this from 180. If I take 180 and subtract 149.655, I get, let's see here, I'll put it right here. This would end up being 0.345 degrees. Okay, so about 30 degrees. So if I want to figure out what this angle is, I could just take 180, subtract 90, and subtract this angle, And that would produce, so this angle would give me, let's put an equal sign here. That kind of looks awkward. So I'm going to erase. Give me a sec. So if I were to find this angle right here, it would give me 59.655. So if I subtract from 180, 90 degrees, and this angle, I get this angle right here. All right, so first problem is already solved. It looks like if I want to travel, so this is question A here. So problem A says that if I want to travel from Phoenix to Minneapolis and I want to find the bearing or the direction, I have to go north. So I'm going to say north, 59.655 degrees east. So usually you write north or south first, or basically whatever direction you're heading towards on the axis. So if you're traveling on like the north axis and then you dip in that direction, you should always explain which direction and what angle is the dip. So I dipped about 59.655 east, but the axis that I'm traveling at first is north. So if I was going south, I would say south, but maybe I dip in towards this side, so I'd probably say south, but then the angle, and then west. All right, let's try to find B here. So if you read B, it says find the bearing from Albany from Phoenix. So if you're traveling to Phoenix, from Phoenix, and then you're traveling to Albany, you need to find the angle and the direction it's traveled. So if I just look at this picture for one moment, this to this, it's still traveling north. Albany is still north. So I know that this is north. And I also know it's still east too, because Albany is east of Phoenix. So I know that this is also east. I just don't know what the angle is, because in order to figure out what the angle is, I need to know what this angle is. So I would need this angle that I've already found and then this angle right here so I can figure out what's the total angle from Phoenix to Albany. So all I need to do is really find this tiny angle right here. And because I already know one of the angles, I can easily figure out that angle by using, I could use law of cosines again, but I don't have to. I could just use law of sines now because I have one of the angles to work with. And this angle right here is the smallest angle to work with. So it's probably guaranteed that I'll get an acute angle. So if I were to create a proportion, I already have little m and sine of m. And I can set this equal to p and sine of p. So my little m here is 368, and my sine of my angle is that ginormous angle, so 149.655 degrees. Sorry if that got kind of smushed. And then p is going to be, let's see, p is right here, so directly across from it is 165. And I don't know what the angle for p is. That's what we're trying to find. So if I want to find this using law of sines, I would just cross multiply. This would be 368 sine of p, and this would be 165 sine of 149.655 degrees, because I would just multiply these two. Okay, let's zoom into here for a moment. So I can divide off 368 to cancel that piece off. Sine of p comes down, and then I'm just plugging this into the calculator. So if I plug in 165 times sine of this angle divided by 368, I get a decimal number about 0.227 if I round to 3 decimal places. So I'll take the sine inverse of that value to find the angle. So if I find the sine inverse, I get 13.121. And I was kind of expecting a small angle because the angle M was very large. So angle P is probably really small. So this angle right here is 13.121. So if I want to know what this complete angle is, to know which direction it's going, I just have to take this angle and add it with this angle. If I do, I get, let's plug it into the calculator. Ooh, I think this E ended up floating around. Let me fix that real quick. There we go. So if I take these two angles and I add them, I get, looking at my calculator, it looks like 72.776 degrees. And it's going east as well. So northeast at 72 degrees, 0.776 east. So from north to east, it's about that much of an angle. And that's basically it.